So far, the only way we know of producing an electric current is by using a battery, which is made of chemicals. And this is fine if you're dealing with small circuits, like in your toys or in your clocks or maybe your mobile phones. But what if you want to distribute electricity on a large scale? Let's say you want to distribute electricity to millions of houses around the world. Do you build large batteries? Imagine the amount of chemicals. What a mess. So I guess the big question we want to explore now is, can we somehow create electric current without using any batteries, without any chemicals? Is it possible? Well, let's find out. We have already seen that if you pass a current through a coil, it generates a magnetic field around it, like a bar magnet, which means an electric current can give us magnetic fields. But a curious man named Michael Faraday wondered whether the reverse was possible. Could magnetic fields create electric currents? Because if the answer is yes, then it's huge, because we would have found a new way to create electric current without using any batteries or chemicals, just by using magnetic fields. So Faraday got excited and he performed a lot of experiments to test this. So you know what? Let's pretend we are Faraday. What kind of experiments would we need to perform to check whether this is true or not? Well, we will require a circuit to have electric current in it. Basically just a coil with some current sensing device, which can tell us whether there is a current flowing or not. Faraday used a galvanometer, which can tell you whether a current is flowing. It can also tell you, depending on what direction the deflection is, what direction the current is flowing. But you know what? Galvanometers are boring. So let's use a bulb instead. And let's assume that our bulb will glow yellow if current flows in one direction, and it will glow blue if the current flows in the opposite direction. That just makes the whole experiment so much more fun. All right? And no batteries, because we want to check whether we can create electricity or electric current without batteries by using magnetic fields. And for magnetic fields, we will require a magnet. So let's bring in a magnet, place it close to this coil and see what happens. And we see nothing. There is no glow in the bulb. That means there is no current, but there is a magnetic field because I've kept a bar magnet close to it. This means a magnetic field does not create an electric current. What a disappointment. So let's pack up and go home. Let's throw away that Wait, I just saw a flash of light. Let's bring back the magnet. Whoa! We saw a flash again. This time it was blue, so the current was in the opposite direction, but we did it. We created electricity without batteries for a split second, but it seems to work only when the magnet is moving, not when it's at rest. And as Faraday, I raise my eyebrows and say, interesting. Now let's play with this even more. What if we keep the magnet at rest and move the coil instead? Do you think we'll create electricity again? Well, your guess is as good as mine. So let's see. And bingo! There we have it. Again, we saw a flash of light when the coil was moving. So this means whether it's the coil or the magnet, one of them have to move, and during the motion, we are getting electricity. But what does this mean? Well, to understand more, let's look at another experiment that Faraday performed. This time, instead of a magnet, he brought in a coil and connected to a battery. The idea is when we close this switch, it'll create there will be a current and it'll produce a magnetic field, and we will check whether that magnetic field will produce electricity in this coil. We will call this as our primary coil, the one that generates the magnetic field, and this one where we're gonna create electricity without battery, we'll call that as our secondary coil. So basically, instead of a magnet, we're using an electromagnet. So, are you ready for this? Let's close the switch and Again, a flash. Are you kidding me? What is going on? So right now, there is a current flowing through the primary. It is generating a magnetic field, but we're not getting anything in the secondary. We only got it for a split second. Man, what's happening? All right, let's open this. Oh, again, we got a flash. So Faraday is trying to figure out what's the secret. What is common in both of these experiments, the one with the magnets and the one with the coil? So can you try and think about what is common in both of them that is generating electricity? Think in terms of magnetic field and see if you can crack the code. Now, if you couldn't crack the code, then don't worry too much about it. It's not at all obvious. But here's what Faraday discovered. If we go back to our coil and the magnet experiment, we saw that when we moved the magnet close or moved it away, that's when the bulb glue. But what's happening to the magnetic field that is going through the coil when we move the magnet? If I move the magnet closer, notice the magnetic field strength increases because it comes closer to the magnet. And when I move the magnet farther away, the magnetic field going through this coil decreases. And since it's during that time we found a flash in the bulb, maybe Faraday thought that a changing magnetic field passing through a loop is what produces electric current. When the magnet is stationary, there is a magnetic field, but it is not changing with time. It remains the same. So maybe steady magnetic fields do not produce electricity, but changing magnetic fields are the one that can produce electricity. Let's see if we can apply the same logic even to the second experiment. In the second experiment, we get a flash when we close the switch and when we open it, but not in between. What's going on over here? Well, when we close the switch, we know a current starts running through the coil. Let's say that current is 1 ampere as an example. Now before closing it was 0, now it is 1 ampere. But the question is, does the current jump from 0 to 1 suddenly? No. It goes from 0 to 0.1, then 0.2, then 0.3, and all the way to 1 ampere. This happens very fast in a matter of few milliseconds, so we cannot detect that, but it takes some very small time for that to happen. And so it's during that time, just after we close the switch, the current is growing to its maximum value, 1 ampere. And during that time, the magnetic field generated by that coil is also growing. And so the field through this coil is increasing. It's changing. And it's during that time, the current is produced over here, and that gives us a light. Since the time taken for that growth is very small, we get a flash of light and then it disappears. Once the current has reached its maximum state, 1 ampere, or maximum value of 1 ampere here, then the magnetic field is not changing anymore. And therefore, after that, there is no more a current produced. And the same thing happens when we open the switch. The current dies out, but it takes some time for that current to die. And during that time, even the magnetic field dies out, magnetic field is changing, and we see a flash. So what Faraday had discovered through these experiments is that a steady magnetic field does not generate an electric current, but a changing magnetic field does. That's the secret. So the current that is produced over here, or we can also say a voltage is produced because of which the charges are moving and we are getting a current. Due to a changing magnetic field, we call them as induced currents or induced voltage to differentiate it from the currents and the voltage we get from a battery. And this phenomena is called electromagnetic induction. So electromagnetic induction is a phenomena in which when you change the magnetic field through a coil, it induces a voltage or a current. And when Faraday presented his discovery, one person asked him, "So what? Changing magnetic field produces a voltage. What is the big deal?" Faraday said, "One day, this will power up our entire world." And today, Even after more than 200 years, all our generators, all the electricity that you get at your homes is produced by electromagnetic induction.